Alright, hey, today we are talking about mineral physical properties. And you might be wondering, how do we really identify one mineral from any other mineral on the planet? And the answer is their physical properties. The really cool thing about minerals is that they each have their own unique chemistry, right? We talked about this last time. Each one has its own unique chemical composition. And because they each have their own unique chemical composition, that basic building block, that composition, determines how those minerals will behave, how they act, how they feel, how they look. All of those characteristics are tied to their chemical formula. So if we can identify physical properties of minerals, we can connect that to a mineral name. And that's why it's really important that we're going to practice back in lab and that we know some information about the common physical properties and the tests that we run to identify those physical properties. Okay, so here we go. The first physical property that we're going to look at is color. And color is the worst way to identify a mineral. I know that's hard because we're people and we have these eyes in the front of our head and we use vision for a whole lot. But color is the worst way to identify a mineral. And that's because of something we call trace elements. Trace elements are these small amounts of other elements that get stuck in that Lego piece structure of the mineral, and it throws off the outside color. Like my favorite mineral, quartz, has a wide variety of color patterns. If it's clear, it's called crystal quartz, or it could be pink, that's rose quartz, purple's amethyst quartz, gray is smoky quartz, and there's a whole lot of other variation between all of those. So color, not a good way to identify a mineral. The second physical property is streak. And streak is a really good way to identify a mineral. And the streak of a mineral is the color of the mineral in a powdered form. So how do you get a mineral to be a powder? You take the mineral and you rub it against a tile that we call streak plate. Some minerals will leave behind a powder on the tile, and that's what we call their streak. And that powder is a good indicator of the mineral's name. The most common mineral that we use streak to identify is hematite, and that's the little video clip that you're going to see. Hematite can come in a variety, again, of outward appearances, from being almost metallic and gray to being almost like a really big chunk of red sidewalk chalk. But it doesn't matter if it's specular and gray or if it's the sidewalk chalk. On the tile, it's always going to show a reddish brown streak. So that's a good way to identify hematite, that reddish brown streak. The third physical property is luster. And luster is just simply a description of how light is reflected off the surface of the mineral. So we just use adjectives to describe luster, things like metallic or dull or pearly or glassy, things like that. Just adjectives that describe how light is reflected off the surface. Sometimes it can be helpful to identify a mineral, but it's not one of the first tests you should run. The fourth physical property is crystal form. And crystal form is the outward appearance of the internal arrangement of minerals. Okay, those individual Lego pieces, that smallest building block of a mineral, it bonds together with other mineral crystals. And as they grow larger and larger, the way they connect produces a particular shape on the outside of the mineral. And there's not an unlimited amount of crystal forms, so there might be more than one mineral that show the same crystal form. And that's okay, because what we're doing when we see crystal form is we're taking a very big, long list of minerals and narrowing it down to just a handful that share a similar crystal form. Number 5 is the most important physical property of a mineral, and that's the hardness. Hardness represents how strong the bonds are that hold that mineral together. Where low numbers on Mohs scale of hardness, that's actually what you call it, Mohs scale. Mohs scale of hardness, a 1 would be very soft and a 10 would be the hardest thing on our planet, like a diamond. And so when you pick up a mineral and you don't know what it is, the first thing you should do is run a hardness test. And we have these known hardness of objects that we kind of test the mineral against. So if you pick up a mineral, the first thing you should do is try to scratch your fingernail, okay? Because your fingernail has a hardness of 2.5. If the mineral scratches your fingernail, you know it's harder than 2.5. You can move on to the next material, which is a penny. And the same thing, you take the mineral and you try to scratch the penny. And if you can scratch the penny, the mineral's harder than 3.5. Then we go up to the next material, which is glass. Glass has a hardness of 5.5. So you put the glass on the table and you try your best to have that mineral scratch the glass. If it scratches the glass, it is harder than 5.5. The next material would be steel. And you place the steel on the table. Sometimes it's a nail, sometimes it's these metal scoops that we have in lab. And you rub the mineral over the steel, and if it can scratch the steel, it has a really high hardness, okay, greater than 6.5. And there are not a whole lot of minerals that have a hardness of that high. So again, this is a test where you start out with this big long list of minerals, and by running one test, finding the hardness, you can take that big list of minerals and narrow it down to just a small handful. And then using your other physical property tests, you can narrow it down again and again and again until you're left with one mineral name. So it's almost like the process of elimination, and that's how we identify minerals. 6 and 7 are the ways that minerals break. When a mineral breaks, there's one of two options. It can either break along flat surfaces, which we call cleavage, or it can break along uneven surfaces that we call fracture. And cleavage and fracture, again, is a really useful way to identify a mineral, to narrow that list down. And cleavage is produced when all of the weak bonds in a mineral, they all line up on the same plane. Okay? So because all of those weak bonds are on the same plane, when that mineral is hit by a force, like hit with a hammer or dropped on the ground, the weak bonds are always the bonds that are going to break. And since the mineral that has cleavage has all of those weak bonds on the same plane, when it breaks, it makes a very flat surface, a clean break. That's cleavage. Fracture, on the other hand, is when those weak bonds are just scattered randomly, all willy-nilly, all over the place. And so when it's hit with a hammer, dropped on the ground, that's how the outside of the mineral breaks. Very irregular, there's no flat surfaces at all, and that represent fracture. Number 8 is density. Okay, density is really just defined as the mass per volume of an object. So we're talking about mass, we're talking about how much it weighs. And in your head, when you see an object, your brain automatically, without even thinking about it, your brain automatically predicts how heavy you think that object should be. And I'm not saying like, oh, I think it's 2.5 pounds, 2.6 pounds. It's just a feel. So when you pick something up that has a high density, it's gonna feel heavier than your brain told you it would. And that's the case with some minerals. Some minerals, their physical properties include a very high density, meaning that you're packing a whole lot of molecules into a small space. So when you pick it up, it's going to feel heavier than your mind thought it would. And the mineral we'll see back in lab and we'll talk about most often is galena. And number 9 is just simply distinctive properties. And with distinctive properties, we're just talking about any unique property that didn't fall into one of the previous categories. And sometimes there's really helpful distinctive characteristics of minerals that help you identify them. The one that pops into my head first is halite. Halite is just table salt. So when you pick halite up and you taste it, like you can taste it, it's gonna taste like salt. It has a salty taste, and that is a distinctive property. Another mineral that just pops in my head is sphalerite. Sphalerite has a very unique streak. And it's not the color of the streak, it's gonna be a light brown, okay, nothing too special there. But the streak of sphalerite is gonna stink like rotten eggs. So you can make a powder on the tile, and after you look at the color, you should always take a sniff, a little smell of the powder. And if it smells like rotten eggs, kind of that sulfur smell, that could be your sphalerite. That's going to wrap it up for mineral physical properties. And just remember, these physical properties are really important because it helps us identify a mineral. Because a mineral has a unique composition, every single mineral has a unique set of physical properties. No two minerals will have the exact same set of physical properties. So when we test for them, it helps us to identify a mineral. Okay, make sure you're asking questions in class, and I'll see you later. Thanks.